So today Einstein heat capacity of solids. I am Dr. Gerald Anthony, Assistant Professor in Chemistry, St. Xavier's College, Palayamkottai. So in heat capacity of solids, the kinetic energy per mole is considered to be 1 by 2 RT and it is along one axis. So in same way, kinetic energy per molecule is 1 by 2 kT, and also so here you can see the total kinetic energy per molecule is 1 by 2 kT, and the total kinetic energy per mole in 3 axis will be 3 by 2 RT. So CV dou E by dou T at constant volume is equal to dou by dou T. So we have to substitute the E value as 3 by 2 RT. So CV is equal to 3 by 2 R. And also for ideal solid element, so there will be RT, energy per axis will be RT. Since we are having 3 axes, RT plus RT plus RT, 3 RT. So instead of E, we are substituting the 3RT value for solids. So the heat capacity at constant volume will be 3R is equal to 25 joules per Kelvin per mole. So in Einstein theory of heat capacity of solids, so it is assumed that there are simple harmonic oscillators, n number of independent simple harmonic oscillators with the energy value E is equal to h nu is present. So the energy for a vibrating diatomic molecule EV is equal to RT into U power U divided by E power U minus 1. So we are substituting the U value as h nu by kT. So now what happens? Instead of U, we can use the value h nu by kT. So this is the value. So as soon as you have substituted the U value, you can see there will be a T in both numerator and denominator, which can be cancelled, and the E vibration energy value will be without T as such. This is equation number 1. Next, average energy of an oscillator can be found using the formula vibration energy divided by total number of molecules. So now you know the EV value from equation 1. We are substituting that EV value, and there is an N value which is already present in the average energy of an oscillator, which is highlighted in this equation in red color. So Nk already we know is equal to R. So in denominator, instead of Nk, we can substitute the value R. So there will be two R in the numerator and in denominator, which are highlighted in black and red color respectively. So both the R can be cancelled. So now you will be having average energy as h nu by E power h nu by kT minus 1. So there are total 3n number of total vibrational modes. If you want to find the total vibration energy, now in the same average energies, we can substitute the value 3n in the numerator. So we are substituting the 3n in the numerator, and we are getting the total vibration energy as such. So now you know the formula for heat capacity at constant volume, that is dou E by dou T. So here we are having E vibrational total. Now you are substituting that value. So when you are substituting here, you can see E power h nu by kT by minus 1 will be in denominator. When you bring it to denominator, as a numerator, it will be converted into E power h nu by kT power minus 1. So it is we can differentiate it according to the formula x power n is equal to n into x power n minus 1. So based on that formula, so when you differentiate it, minus 1 into e power h nu by kt minus 1 whole power minus 2. Now again e power h nu by kt will be differentiated, 1 will disappear. Again the h nu by kt will be differentiated. Now the t is in denominator. When you bring it to numerator, it will be converted into t power minus 1. Again it should be differentiated based on the formula x power n. So minus 1 into t power minus 1 minus 1, that is minus t power minus 2. When this minus 2 is brought to denominator, it will be converted to minus 1 by t square. So that is here we are having minus in the numerator and t square in the denominator. So already we are having minus 1 here. H nu by kt square is also carrying a minus, so minus into minus plus. So now we can see we can divide the k with divide and multiply k in this above CV value. So when you do like that, so I have highlighted the k in the numerator and denominator in red color. So already you see there are h nu and here also h nu into h nu the whole square. Already there is a t square in the denominator, and also now you have introduced a k. Already the k is present in the denominator, that k is highlighted in green color, and the newly introduced k is highlighted in the red color. So k into k square. So all we are having h nu by kt the whole square, and h nu is also there twice, and k is also twice, t is also twice. So you can write it as such h nu by kt the whole square, which is written in the next slide. So you can see h nu by kt the whole square. Now you are having nk. So instead of nk, we can substitute the formula r. So nk is equal to r. Okay, nk is equal to r. So we are substituting nk. Instead of nk, we can substitute the value r. Now you are getting cv, heat capacity at constant volume. This is as considered as equation 2. So at high temperature, the h nu value will be less than kt. So in h nu by kt value will be obviously is less than 1. At that circumstance, instead of e power h nu by kt, we can use the term 1 plus h nu by kt. So you can use the term 1 plus h nu by kt. So instead of, so in numerator you are having e power h nu by kt, which is highlighted in blue color. In denominator also you are having e power h nu by kt, which is highlighted in red color. Instead of that the two values, you can use this 1 plus h nu by kt. So when you please note down the equation 2 in your paper. Now if you substitute it, now you can see what happens. So the equation 2 becomes like this. So you are having plus 1 minus 1 both in the numerator in the denominator, which can be cancelled. And another thing, you can see that there is a 1 plus h nu by kt in the numerator. So since the one value will be 1 plus h nu by kt value can be replaced with 1. So in numerator you are having 1 plus h nu by kt. That value is replaced with 1 because h nu by kt value will be very much smaller than 1. So it can be replaced in the numerator. So now what happens? So in the previous slide you will be having 1 plus h nu by kt. Now it is replaced as 1. Now you can see there is a h nu by kt the whole square in numerator and denominator. So both are represented with highlighted with the green and red color. So both can be cancelled. So CV is equal to 3R. This is one heat capacity at constant volume at high temperature. At low temperature, H nu value will be very much lesser than KT. So in equation 2, if you have noted it, you can see that the only one thing is you just omit the minus 1 which is present in the denominator. Here in denominator you will be having minus 1, just you will be omitting that minus 1, that's all. Remaining all the other equations will be used as such for low temperature condition. So you can see here you are having after applying this condition in red color I have marked in denominator e power h nu by kt the whole square in denominator, and e power h nu by kt is in the numerator blue color. So you can cancel e power h nu by kt, e power h nu by kt the whole square. So you will be obtaining only e power h nu by kt in the denominator. both can be cancelled. So here you are having 1 e power h nu by kt here also. So when you are doing like that, so only the e power h nu by kt will be remaining in the denominator. So this is the heat capacity at constant volume at low temperature. Now you can remodify it, and the CV is equal to 3R. So h nu by kt square. Now you are bringing this e power h nu by kt to numerator. So it will be e power minus h nu by kt. So next class we can see the Debye heat capacity of solids. Thank you.